Hello, everybody. Welcome to IST 110. I'm, of course, Professor S, and this is today's lecture. Now, it's going to be a little light today because the idea is I wanted to give people time to work in their groups. So I didn't want to spend too much time talking because this is a designated time that all y'all have to work together, and I wasn't sure how much time, how otherwise groups had their times could synchronize so well. So anyways, what we did today was I talked about the group project for a little bit, gave some reminders, and then lectured on the Zybooks that were due for class today. For the group project, just some reminders, and this is just about the video. We'll talk about the report on Monday. Okay, the video project is due before class on Monday, so make sure your group gets it in on time. There's a few groups that have already submitted their video, and that's great. The topic needs to be how technology is influencing or being influenced by a group, right? It's not just like the technology. I need to know about a little bit more about that technology and how it's what it's doing to a certain part of society or how a certain part of society is using it. Okay. And then after the quiz, so on Wednesday, we'll continue talking about stuff. And I will, on Wednesday, what we'll do is we'll take the quiz and then we'll start watching the videos. Okay? All right. So one of the things that we're going to be talking about is computer abstraction. And it's a very important part of working with computers. And I want to make sure we emphasize it because it's kind of hard to approach at first, but like once you get the hang of it, it's pretty easy. And so the analogy that I'm going to start off with is thinking about learning how to read. Okay. And so when you first learn how to read, you learn letters, right? You say, this is an A, this is a B, this is what it sounds like, and that sort of thing. And then once you get those, you start putting them together and forming words, right? So it's like, well, T and H, when you put them together, they don't really sound like they usually do. They make a new sound. And when it's used in these words, this is what it means, right? And then from there, we go into sentences, and then we go into chapters and summarizing text, and then you start thinking critically about the text. This is like the general progression for literacy in general, at least in the States. And the thing is what I want to kind of emphasize is when students are starting to learn how to read and that sort of thing, we don't go into critical thinking about text. Like, what do you think the author was really thinking? What do you think the message is? How can we benefit from this? It's just, how do you pronounce these letters, right? Because the thing is like when you focus on those more early things. I mean, they're all, each one of these things is super important. But when sometimes it's important, like when you're working on chapters, to not have to worry about how to pronounce letters. Because when you're working on how to pronounce letters, you can't make sense of a sentence. Likewise, if you're struggling with what a sentence is, or like what each sentence means, you can't think critically about a text, right? And so that's kind of like one of the things that abstraction does is instead of like having to think of these mundane things, it allows for broader things to be addressed, right? So kind of think of it, the whole point of abstraction is to kind of know as little as possible about what you're using. You know what you can do with it, but you don't really need to know exactly how it does what it's going to do, right? So, okay. So think about, like, the example that I gave my class was my calculator here, right? So I know that when I do 56 plus 2, that I'm going to get 8, right? So I know that's what I'm going to get. Or if I know that if I add two numbers together, I'm going to get the sum on my calculator, right? Now, the thing is I don't know exactly how it's doing that, how the CPU is working, what's the specific configuration for the numbers to get to do with what it's supposed to do, but I do know that it works. And that's that's like how the abstraction works. And the interesting thing is when we get into more complex devices like phones and computers and tablets and those sorts of things, there's different levels of abstraction, right? So, like for instance, I don't know how like the specific code for Word is, but Word works with a bunch of different things, and so I can expect it to work. And so then when we look at that next layer of programming, I don't know how um, the developers of like Canvas, they don't know how like if you're incorporating something with Microsoft or something like that that's embedded in there, they don't necessarily know how Microsoft's products work. They're not looking at their source codes. What they're doing is they're working with a thing called an API, an application programming interface, that allows them to talk with that other program within the code. Okay. So the idea is like they're able to do their job of programming Canvas and allow it to work with Microsoft without actually having Microsoft like opening up their hood and saying, "Here, take a look at all of our source code." It's just able to get things to work, and it's through that abstraction. So one of the reasons that abstractions is important is that it allows businesses to work together without sharing all their secrets, right? Without sharing like how all their proprietary stuff is done and all that sort of thing. So abstraction is definitely important in that regard. So like another example of APIs is Watson. So Watson is a AI thing that's AI service, I guess, from IBM that people can use in their program to work. So I guess cloud computing in a sense. But the idea is like people can use that without actually getting the code for Watson. They get these functions and things like that they can use with the service to use in their program. So APIs, it provides functions and things like that allow the programmers to use the software and or hardware in their thing without giving complete access to everything. Okay, it's kind of a licensing thing that is allowed, and so that's one way that abstraction is used. Another way that abstraction is used is with modules in a group. So in a software development company, people that make software, they don't have everybody doing the same thing, right? That's inefficient. Why make everybody do the same thing? And also at the same time. So what they do is they come up with these different parts that people need to take, that of these different things that need to be addressed, and divvy it out to people that can handle it. Okay, and so everybody works on their different parts, and these different parts are modular. They're modules that people work on, and they work together as a group. Okay, so everybody does their part, and they somehow put it all together. Okay, and so the thing is like with these different modules, some of these modules aren't even built yet, or some of them are, but the important thing is like the person working on their module doesn't necessarily know what somebody else is doing with their module, but they still need to know that it can work, right? So they know that they can work on these objects here, and so the idea is like they need to be able to put certain arguments in and know that they're going to get certain arguments back. And I'm not talking about trust sort of thing, trust that they know what they're doing. It's just about like, that's what the machine is expected to do. Just like it's not, I mean, I guess you could incorporate trust into my calculator that's going to give me the right numbers. But the idea is it's the putting the numbers in and knowing you're going to get the answer out. It's like, that's the expectation. It's the expectation sort of thing. It's knowing that that's what it will do, so that when everything works together, it will work together. Maybe what I'm talking about with trust and making sure people know what they're doing is the idea is I guess you want to make sure that your part isn't failing, right? Because you're working with what you were told, like if you're a developer, that your module is doing what it's supposed to. It's taking the arguments and sending out the responses like it's supposed to. and that's it. Like that's your contribution. The other thing that's kind of important for abstraction is like thinking about software development is that you will create your own objects and stuff like that, and instead of having to think about like, all right, will this work with this thing and this thing, it's just like, all right, this will work. And it kind of, okay, to kind of allow for a analogy, so like in Java you can create objects and you can create methods and that sort of thing, and one of the purpose of those is so that you can reuse it. And that's another purpose of abstraction, is being able to reuse something without having to recreate things from scratch. It's to speed up the process. Okay. The one other thing that I want to talk to you about abstraction before we incorporate it more with languages is thinking about the different levels. Is like, do you really need to know how the computer turns your code into something that the computer will recognize? I mean, there, like I said, there's different levels. So, like, it's like knowing how your so one level would be like, if you're programming, would be how it incorporates with the operating system and working with the kernel. And then there's also another level below that, which is like working with the rest of the system, thinking about like drivers and things like that. And then we get down to the ones and zeros that the CPU is pumping through, right? And the arithmetic unit and all those different things. So the idea is like there's different levels, and it's important for abstraction that you don't have to worry about those things, so you can work on those bigger things. So like, I know this works, so I can reuse this. I know this works, so I can get these other things to work with it. That's the point of abstraction. It's kind of one of those things that like mastering abstraction is something that you it takes a little getting used to at first, and it but then you eventually take it for granted. It's just something that becomes a part of life. Just like when reading, you don't really need to focus on the pronunciation of letters so much. You just focus on what the text is saying. Okay. So anyways, with programming languages, it kind of incorporates a lot of those different things with abstraction into it, because as history has progressed, we've come up with different generations of computers, right? Different and different, not just generations of computers, but different types of languages. And as we've progressed, for the most part, what happens is the earlier the generations are more for the machine, and the further generations are more for people, right? It's more conversational for people, and less ones and zeros. So anyways, for those first generation, it was machine language. So they were essentially pumping in the ones and zeros into the CPU. CPU was pumping out the ones and zeros. And so somebody had to make sense of what all these ones and zeros should go in and what were coming out, right? The computer was doing a lot of the thinking, but there's a lot of thought that came into interpretation of what task do I need to have happen? How do I make the computer do it? How do I read the responses, right? And so then there was assembly, which came later, and assembly essentially put letters and words to those ones and zeros. So it's still like things map onto it, but instead of having 000101000 or whatever, it would say, it would have words that would say open this, verb, number, like these sort of things, verb, noun, verb, noun, like those. It was very, very simple things. And then what happened was it still required an extensive amount of interpretation and translation from the machine to the person, and the person to the machine, right? So then there came later languages like third generation. And this is where it was very procedural and object-oriented. And it was a lot of, like, the big difference between this is, like, the development of compilers, right? And so, like I said before, with the abstraction, one of the things is you could do a line of code that did a bunch of different things in assembly. And that was huge. It saved a lot of time for people, and it was that level of abstraction made more sense to people, right? So instead of having to think about like what is one, like how do I print this message, it just says print this message, right? Instead, it just avoided those lines of like figuring out what a variable was, posting that variable. It just says print this message. Okay. And then from there, and so some of the examples are like Fortran. This is like one of the earliest ones, and we had C++, Java, and some people consider Python to be a third generation. Another thing that kind of differentiates third generation from the later is the amount of knowledge that it's required to still use it, right? There's still like, usually for third generations, they require some training, right? You can't just like say, in order to use it effectively, you have to practice using it quite a bit. It doesn't. It's not just like look at it and figure it out. And as we get into further generations, it is more like that. But the idea is like since we start using these compilers, that's when we start like differentiating our high-level languages with our low-level languages. Low-level languages are considered machine language, the ones and zeros, and the assembly language, which is not too far off from it, but not. It just looks like weirdly abbreviated words that kind of don't make sense if you're not familiar with it. Now, and let me move on to the other higher level languages. So fourth generation, that's when we have like SQL, R, MATLAB. These are languages that are mostly specialized, like usually for database or calculations. And it's about it's much more approachable. But the thing is that it's also much more specialized too. So, like for instance, you can make so many different programs with like Java or C++. A lot of games are are programmed in C++, and you can do other things in C++. You can make a database. You can do all these other different things with that thing. But like with a lot of the fourth generation programming languages, you might not be able to do that with you. So like for example, SQL, that's for database work. If you can make a game with SQL, I mean, that's cool. I don't see how that's really possible. It's not really designed. It doesn't really work that way. What it's designed to do is make it a database programming very approachable for people. It doesn't take tons and tons of training. Like it does take like a little bit of work to start getting used to it, but it's not the same kind of level of training that's required for those third generation computers or languages. Fifth generations are supposed to be the next level thing, and it's interesting because they popped up in the 80s, but I don't really see them being used. I said Prolog as an example, but I don't really see these like used as much. I think if they're going to be used, it's gonna come later. But the thing is like they're not as approachable. They're not. I mean, they're the idea is that they're more approachable, but I think the thing is like they're harder to find as good of use as the more versatile generations before it. So more approachable, but harder. It does, like when you're creating these more approachable things, you're kind of giving up the flexibility to do those different things. So like assembly, it can actually do more than some of those third generation things. And so that's actually why assembly language isn't gone completely. It's still being used like for drivers or like things like that. But the thing is like those it's people don't really use assembly loving it. It's not something that people love using. It's not very user friendly, and so people try to avoid it if they can, and so they use more high level languages. That could be why Python is the preferred thing for doing a lot of AI coding, is because it's very approachable. And Python, admittedly, is kind of like some people would argue it's third generation. Some people would say it's fourth generation because it's very script like. But I'm going to say it's third generation. I'm not going to require you to like split hairs on saying like, oh, okay, well, Python would be third generation. Visual Basic, I'm going to say that's fourth generation. It's like some of these things, it gets iffy as to like where they go. So that's why I tried to give these more concrete definitions. So like SQL, that's definitely fourth generation. R, that's definitely 4GL. MATLAB, yeah. But yeah, anyways, those are those different programming languages. And notice like there's also that level of abstraction. So having to it's like the compilers that were introduced in the third generation, there's that extra level with the SQL, because SQL, R, and those sort of things, they can do in one line what it takes lines of code to do in those third generation. Okay? So anyways, I think I've talked about enough of these. What I'm really wanting you to take away from this is kind of basic differentiation between these different generations. Know the difference between low level and high level. That's also important. The high level, that's when you have compilers and it's considered much more user friendly. Low level is the emphasis on usability of the computer. It requires an extent, like it's ones and zeros, or it's assembly. Essentially, lower level is machine language and assembly language. That's pretty much it for low level. And then high level, everything else. Okay? Anyways, I think that's good for today. I will see you all Monday. Bye. Hey everyone, I hope you enjoyed that video. If you did, please press the like button. It lets me know I'm doing something right. If you have any questions about any of the content, please send an email through Canvas to me and the rest of the teaching team, and we'll get back to you as soon as possible. Do not send it through normal email. You will not get as fast response. These are COVID times, so it could take a little bit, but we will get back to you, I promise. Anyways, if you have any suggestions for how I can make these videos better, please leave in the comments below. Don't forget to roundhouse kick the subscribe button and ring the bell to get notified for when I post the next video. Anyway, I think that's good for now. I'll see you all next class.